Okay, welcome back. So today we're going to talk about chapter 2, and chapter 2 is simply frequency. So as you can see on the board, there are 30 self-esteem scores. By the way, so I'm posting these videos, but these videos are based on my lecture notes that I'll also post. So you can see both, which I think is a definite benefit. So remember last time I was talking about a blob of data. Welcome to your blob of data. Here you have 30 self-esteem scores, right? So on the self-esteem measure, people can score anywhere between 1, which is the lowest possible self-esteem, and 4, which is the highest possible self-esteem. So as you can see in this blob of data, I have 30 self-esteem scores. Well, one of the most basic things we could do in statistics is we can actually organize the data. So the first thing we're going to do is we're going to start with what's called a simple frequency distribution. I'm going to grab a different pen. So the first thing we need to do is we need to indicate all of the possible self-esteem scores. So I told you the maximum self-esteem score is a 4 and the minimum is a 1. And it looks like our data is going by 0.1. So just we're going to start with the highest possible value, which is 4, and we're going to work our way down. So what I want you to write in a column, and I'll probably have to do 2 columns because I'm going to run out of space, is I want you to go ahead and write 4, 3.9, 3.8, 3.7, 3.6, all the way to 1. So I'm going to go ahead and do that right now as you do that at home. I'm going to adjust my columns, so just keep on doing what you're doing. Okay, great. So what I did is, as you can see, I had to use 2 columns, but I've numbered this column, I just called it SE for self-esteem, and I numbered it from 4, 3.9, 3.8, blah, 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 all the way down to 1. Okay, so that's great. So now essentially what we're going to do, this is going to be the base that we're going to hang these data on, right? So essentially we're going to go through every single value and I'm going to say how many are there. And what I want you to do is I want you to look at your raw data here and figure out the count. So let's go ahead and do this. As I go through, I'm going to circle them so it's very clear. Okay, so how many 4s do we have? Let's scan, 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 scan. I see 1 and I see 2 4s. Okay? So in my tally, I'm going to put 2. You know, before I go on though, I'm going to do something that's going to help us out. I'm going to make little red dots to separate all the values because otherwise we're going to get kind of confused as we go on. And this is something, you're probably using lined paper, so you already have these lines that I'm drawing in. But that's all I'm doing, nothing more than that. Just making lines so I don't lose track of the data. So as you can see, I just threw in a whole bunch of lines there. Okay, sorry, I'm gonna grab my cap. I lost it on the ground. No, I lost it again. Okay. And let me grab a different green pen. This one's not as bright as I want it to be. Okay, so we found that there's 2 4s. Yeah, that's a little better. So then the next question is, how many 3.9s are there? Okay, so look for the 3.9, look for the 3.9. Do we see it? Looks like we have one 3.9. Now we're going to look for the 3.8s. So same procedure, look, look, look. I find 1, 2, 3, 4, and 5. Yep, that seems right. So I'm doing my tally marks here, you know, just as like a rough draft frequency count, right? Nothing more, nothing less. So there's 5 3.8s. What about 3.7? I see 1, I see 2, I see 3, I see 4, I see 5. So once again, I have 5 3.7s. What about 3.6? Let's take a look. 1, 2, 3, 4, 5. I have 5 3.6s. What about 3.5s? 1. Looks like I just have one 3.5. Okay. Let's look at 3.4s. 1, 2, 3. Yep. 3 3.4s. What about 3.3s? Let's take a look. 1, 2. Okay, I should only have 2. Great. What about 3.2s? 1, 2. Okay, 2 3.2s. 3.1. I have 2 3.1s. What about 3s? Okay, 1 3. What about 2.9s? 0, 2.8, 0, 2.7, 0, 2.6, 0. I don't have another count until 2.3. Okay. So once you do your rough draft tally, okay, you can go ahead and write your frequency. So you see that squiggly F that I drew? That squiggly F right here, squiggly F, squiggly F. Okay? That means frequency. So just plug in a number there. So I have 2 4s. I have 1 3.9. I have 5 3.8s. I have 5 3.7s. 5 3.6s. 1 3.5. 3 3.4. 2 3.3. 2 3.2. 2 3.1. 1 3, and then the rest I have 0 0 0 0 0 0 1 0 0 0 0 0 0 0 0 0 0 0 0 0. Okay, so there you have it. That's a simple frequency distribution. So what did we do? We took this blob of data and we organized the scores. Now, very easily, you could tell me what the highest score is. So what's the highest score? It's a 4. What's the lowest score? Well, there it is. It's a 2.3. What's the score or scores that occur most frequently in this distribution of data? And that's what we call the mode, by the way. So the mode tells us the value, in this case, the self-esteem value that occurs the most in the distribution of data. So which value or values occur most in the distribution of data? Well, here you go. 1, 2, 3. 3.6, 3.7, and 3.8 are all self-esteem values that occur 5 times. So they are all the modes. So, because our data is really clumped, it's telling us a lot already, which is a good thing. It's telling us a lot, right? It's telling us, well, hey, it looks like a lot of people are scoring really high on self-esteem in this distribution, right? Because the lowest possible score is 1, the highest possible is 4. Well, look, a majority of people are 3 or higher. And this is a little extension. This is something we call relative frequency. So give me 1 second. I want to figure out what I'm going to do. Let me make sure I'm doing the right thing. I'm going to go ahead, because we have limited board space, I'm going to go ahead and I'm going to erase the raw data. So let's say goodbye to the raw data. And then I want to show you a concept that is known as relative frequency, but you probably just know it as something that you can figure out on your own. It's really not difficult at all. So again, the point of us doing data analysis is to take the blob of scores that we just took, reorganize it in a way that's starting to tell us something more than nothing, which is great. So the next concept I want to talk about, like I said, you already understand this. The formal name is relative frequency. And all you're doing with relative frequency is you're dividing one category or multiple categories by the total in order to make a percent statement. So, for example, if one thing I would say as a researcher, based on what I see in this simple frequency distribution, is I would say, okay, well, here, let me, 3 and higher seems important. So how many participants scored 3 or higher? And the answer to that is going to be 29, right? Let me use a different color. So 29 participants scored 3 or higher out of what? 29 out of 30. So go ahead and do that calculation right now. So 29 divided by 30. So you can make the statement. You can make the statement that 97%, and that's 29 participants, of the participants. Here, I'll write it up and then I'll talk about it. %, or 29 of the participants in the distribution of data had a self-esteem score of 3 or higher. Okay? Yeah, that's a great statement. Makes a lot of sense. It really defines what it means. One thing that you'll see when you look at the notes is I posted the self-esteem measure in the folder for chapter 2. So you'll see when you're looking at the anchors for the self-esteem measure, you'll see that one is disagree, or rather strongly disagree. 2 is disagree. 3 is agree. And 4 is strongly agree. So essentially, if someone agrees with the statements, of course there is some reverse coding that goes on, which we're not going to talk about. But if everyone, if someone says 4 for every single statement, so they're essentially agreeing that they have high self-esteem, as opposed to someone who says 1. So if someone answers 4 to every single question, you take an average of that, they're going to have a 4. So they're going to have really high self-esteem. If someone answers 1 to every question, you take an average of that, they're going to have low self-esteem. So there's something called reverse coding where some of the questions have to be turned in a different direction. But I'm just telling it to you in a simplistic way that relates back to the scores here. So essentially, these people who are scoring a 3 or higher are agreeing or strongly agreeing that they have essentially high self-esteem. So I hope that makes sense. So let's see if we could add that context into the statement just to make it a little clearer. So 97% or 29 participants in the distribution of data had a self-esteem score of 3 or higher. Okay, meaning we could say 3 or higher, indicating really high to very high self-esteem. So that really gives it a little more context. But that's relative frequency. Relative frequency is taking a grouping of the values, dividing by the total, just to make a percent statement about the distribution of data. That's something I think everyone would intuitively, attempt. The next concept we're going to talk about is the concept of grouped frequency. So this is grouped frequency distribution. This is used when the range of scores is too large for a simple frequency distribution. Usually when the range of scores is greater than 20. Yes, that is the case here. When it's talking about range of scores, what is it talking about? It's talking about possible scores, not the actual scores that we have in our distribution of data. So we're talking about possible scores, we're talking about 4, 3.9, 3.8, 3.7, 3.6, etc. So let me count out how many possible scores there are for us. Ready? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31. So there's 31 possible scores. So that's our range of scores. Let me write that over here. We have 31 possible scores. We do a grouped frequency when the range of possible scores is greater than 20. So 31 is greater than 20. So we are not content with our simple frequency. We want to do a grouped frequency. So in order to determine the amount of categories, we need to group. We have to divide by a number, and our goal is to have about 10 categories, somewhere around there. So let's try it out, right? So it's very simple. If we have 31 possible categories, let's take 31 divided by 2. Okay. What this is saying is if we group 2, 2, 2, 2, 2, 2, 2, so if we group the categories 2 by 2, we would now reduce our total number of categories to 15.5. Let's see if we can do a little better, and let's see if we can get closer to 10. 31 divided by 3. Divided by 3 should be 10, I think it's 10.33, right? But let's check. Yeah. Okay, so if we do 31 divided by 3, so meaning instead of doing groupings of 2, we're going to do groupings of 3, we're going to end up with 10.33 categories. This sounds great. So because we had 31 categories, we had to group them in order to get closer to 10 to make our summary, our frequency summary of the data better, essentially. Okay. So we determined our number is 3. So we're going to do the same sort of thing, right? We're going to have our self-esteem column. We're going to have our tally column. Well, actually, we're going to have our midpoint column. And we're going to have our frequency column. Okay, so now work with me here. What we're going to do is we're going to do our groupings. So how are we going to do that? We're going to go over here, right? And we're going to say, okay, we're going to group 3 by 3. Let's do it. So our first grouping is going to be 3.8 to 4, right? Okay. Our next grouping is going to be 3.5 to 3.7. Okay. Our next grouping is going to be 3.2 to 3.4. Then we're going to have 2.9 to 3.1. And then we're going to have 2.6 to 2.8. And then we're going to have 2.3 to 2.5. Then we're going to have 2 to 2.2. .7 to 1.9. 1.4 to 1.6. 1.1 to 1.3. So we have a little bit of a problem, okay? Our 31st category, which is 1, doesn't have a 32nd and a 33rd category to be grouped with. So essentially what we're going to do is we're going to add some categories. So 1, 0.9, 0.8. So even though 0.8 and 0.9 aren't possible scores, we're going to just add them in there so 1 isn't going to be by itself. So that's the logic there. So we'll do 0.8 to 1.0. So one of the reasons I like group frequencies is I just have 1 column instead of 2. Because I always run out of board space, it never fails. So I'm going to go ahead and add in my lines. Okay, let's do it. Okay, great. The second column is midpoint. So what's the midpoint? Well, it's simple. It's going to be the middle category. Okay? So, or another way I guess you could look at it would be the average. And I actually believe the equation for midpoint is going to be 4 plus 3.8 divided by 2 for the first one. So let's check that out. 4 plus 3.8 is going to be 7.8 divided by 2. So your midpoint is going to be 3.9. Okay. So basically, just add the first number of the category plus the second number of the category divided by 2, and you'll get your midpoint. So I don't typically use midpoint, but I'm just teaching it to you because other people do. I would much rather show the interval, which you'll see we're going to do some graphics in a little bit, and I show the interval, some people show the midpoint. I'll talk more about it then. Okay, so the midpoint of 3.5 and 3.7 is going to be 3.6, 3.2 and 3.4, 3.3. 2.9 and 3.1 is going to be 3.0. 2.6 and 2.8 is going to be 2.7. 2.3 and 2.5 is going to be 2.4. 2 and 2.2 is going to be 2.1. 1.7 and 1.9 is going to be 1.8. 1.4 to 1.6 is going to be 1.5. 1.1 to 1.3 is going to be 1.2. 0.8 to 1 is going to be 0.9. So figuring out the midpoint is really, besides the intervals, that's the only thing that's different between the simple frequency distribution and the grouped frequency distribution. So as you can see, our third column is the tally marks. So essentially, look at the first category, how many scores are between 3.8 and 4. So essentially, because we already did the simple frequency distribution, we could just aggregate these numbers and put them over there. So 3.8 is 5, 3.9 is 1, 4 is 2. You add them up and you have 8. So that's all you have to do there. So again, we can do tally marks. So 1, 2, 3, 4, 5, 1, 2, 3. Okay, 3.5 to 3.7. 3.5 is 1, 3.6 is 5, 3.7 is 5. It gives you 11 for that category. Okay, 3.2 to 3.4. 3.2 is 2, 3.3 is 2, 3.4 is 3. That gives you 7. There you go. Okay, which one are we on? We're on 2.9 to 3. 2.9 is 0, 3 is 1, 3.1 is 2, so that gives you 3. Okay, the next category that we actually have something is 2.3 to 2.5, and that's going to be 1. So we can go ahead and write up our frequencies. So 8, 11, 7, 3, 0, 1, 0, 0, 0, 0, 0. And something that's really simple, but it's important to check, is add everything up. Make sure you still have 30 scores and you don't have 28 or 32, right? So this is something that's important. Always find ways to check your work. Okay, so 8 plus 11 is 19, plus 7 is 26, plus 3 is 29, plus 1, so our total n is still 30, which is a good thing. We didn't lose numbers, we didn't add numbers. There you go. Okay, so this is what our grouped frequency distribution looks like. So again, it's telling the same story as the simple frequency distribution, it's just more compressed. This simple frequency distribution is actually pretty good because the values are pretty much 3 and above, right? What was it, 96% of the values are 3 and above? So the shape actually looks kind of good. But imagine if every single category was like a count of 1 or maybe 2 or 0, and there really wasn't much going on. We really couldn't see anything. So then that's why the grouped frequency really helps out. So frequency distributions are useful because you can easily identify the maximum and the minimum score. Okay. You can understand the general shape of the distribution. And we're going to talk more about shape when we graph it out, because I think that's when we really start seeing shape. Although, when we're talking about shape, the fact that most of the scores are high as compared to low, that's really meaningful. And using frequency, we can make more informed guesses about central tendency as well as variability. So remember, we talked about central tendency and variability in our chapter 1 lecture, and we're going to talk about central tendency in our chapter 3 lecture. We're going to talk about variability in our chapter 4 lecture. But remember the basic concepts, right? Central tendency is a measure that tells you the most typical number in a distribution of data. Well, obviously, and one of the measures of central tendency is mode. So looking at this, we're not going to say the most typical value in a distribution of data is somewhere around 1. That's definitely not the case. Remember, everything's pretty much clustered 3 or higher. So if we use mode as our measure of central tendency, we can say the most typical value in our distribution of data is going to be either 3.6, 3.7, or 3.8. Now, let's talk about variability. Variability has to do with spread, right? Well, How spread out are these data? Not really spread out, right? A lot of high scores, like one low score. Low variability, low spread, right? A higher spread would be, like I was saying, if there was a frequency count of like 2 to 3 per category. Well, that would be a huge spread. There'd be some people with high scores, some people with middle scores, and some people with low scores. Okay, so there you have it. But again, we're going to go into that more specifically in our Chapter 3 Central Tendency lecture and our Chapter 4 Variability lecture. But you know, that's just a taste. Okay, so at this point, we're done with simple frequency, and we're going to create a frequency polygon and a histogram based on our grouped frequency. So that's our next step. So I'm going to go ahead and erase our simple frequency over here. Okay. Okay, so we're going to work on the frequency polygon, okay? So the first thing you need to do is you need to draw an XY plane. So on the y-axis, you're going to have frequency. So the y-axis is going to represent your count. And remember, frequency is represented by this squiggly looking F. Ready? This squiggly looking F. Okay? Right there. So that's frequency. Our x-axis is going to be self-esteem scores, right? That's what we're talking about. So you could just write self-esteem scores. Okay, now at this point you have a choice. You have the midpoint and you have the intervals. I do not use the midpoint. I like the intervals. But some people, they put the midpoint on there. Fair enough? Okay, so our lowest category, which we're going to put here, is going to be 0.8 to 1. Okay, and then we have 1.1 to 1.3, and then we have 1.4 to 1.6, and then we have 1.7 to 1.9, and then we have 2 to 2.2, and then we have 2.3 to 2.5, and then we have 2.6 to 2.8. So this is going to look really small here, but that's okay. And then we have 3.2 to 3.4. And then we have 3.5 to 3.7. And then we have 3.8 to 4. Okay, great. So again, I wrote down the intervals there. You could write the midpoints, right? And the midpoints can represent the intervals. The intervals represent the midpoints, either way, right? Substitution. Okay. And we have to do one other thing. We have to mark frequency. So frequency can have a count of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and I think our highest count is 11. So I'll stop it at 11 because I almost ran into our frequency polygon. So let's go ahead and graph. So 0.8 to 1, how many values do we have? We have 0, so put a dot there, 0. 1.1 to 1.3, how many values do we have? 0. So let's see. We have 0 until 2.3 to 2.5. And then we have 1. And then 2.6 to 2.8, we have 0. 2.9 to 3.1, we have 3. 3.2 to 3.4, we have 7. 3.5 to 3.7, we have 11. Okay, and then 3.8 to 4, we have 8. Okay, cool. So we have some dots. Now we could just go ahead and connect the dots. So go ahead and connect the dots. Okay, so, problem, but very minor. Our graph looks weird. It looks like a snake. Okay? Our frequency polygon always has to end on the x-axis. How do we do that? We make a fictitious category. We make a fictitious category of 4.1 to 4.3, right? That'll bring it down. So let's do it. And the reason why we're putting in 3 values is because all of our other categories have 3 values. We're keeping it consistent. Okay, I added that fictitious category. Obviously, it's not possible to score 4.1 to 4.3, so I'm going to make it 0. Okay. So there's our frequency polygon. Cool. Okay. Now I'm going to do the histogram. And all I'm going to do is I'm going to erase the line. I'm going to leave all the points. Because the only difference between a frequency polygon and a histogram is the fact that the frequency polygon connects the dots with lines, whereas the histogram, it just has bars that are connected. So I'm going to show you what that looks like. Okay, histogram. Okay, so I erased the line. Now let's make bars. All right, follow me. So this is all flat, right? They're all 0 values. Okay, now ready? Make your first bar. The dot has to be in the center of the bar. Okay? Boom. It goes down, it goes up again. The dot's in the center of the bar. It goes up, the dot's in the center. It goes down, it goes up, the dot's in the center. It goes over, it goes down, it goes over. So as you can see, the dot is always in the center. So the only difference between a frequency polygon and a histogram is a histogram has bars and the frequency polygon has lines. There you have it. Okay, so our next topic is shape of the distribution. So let's go ahead and do it. Okay, shape of the distribution. Now, there are 3 different shapes we're going to talk about, and I'm going to give you one rule today to determine the shape. We'll learn more in chapter 3, I believe, but today we'll just use this definition. So notice, let's start over here. If you take our histogram and you trace a line over it, okay? You see that? There's a lot of high scores and very few low scores. So this tail is pointing to the left, okay? It's very possible that the situation could be reversed. There could be a lot of low scores and very few high scores. So then the tail would be pointing to the right. So I'm going to go over a few scenarios here. So if the tail is pointing to the right, the distribution is said to be positively skewed. So that's simply defined as, like I was saying, there's many low scores and few high scores. So now let's figure out what it means when the distribution, or rather the tail of the distribution, is pointing to the left. When the tail of the distribution is pointing to the left, the distribution is said to be negatively skewed. In this case, there are many high scores and only a few low scores. Okay? And there's just one more scenario. Normal distribution, okay, is where the tail is neither pointing to the left nor the right. So you can think of it this way. Few high, few low, and many in the middle. Okay, so those are your 3 types of distributions and how to identify them. Okay? So now, if you're dealing, you use frequency polygon and histogram when you're dealing with specifically interval and ratio data. Okay, there's an argument. There's a little bit of wiggle room where you can use it for ordinal data. Okay, bar chart, which is the last thing we're going to go over for this lecture, you can only use for nominal and ordinal data. Okay, so ordinal is always that like area where there's a little wiggle room. So I'm gonna erase the board because this is a whole different concept. So we're done with this. I'll give you one last look. There you have it. I'm gonna erase it now. Okay, remember, bar chart or a bar graph, only used for nominal or ordinal data. So what I usually do when I teach this class in person is I tell people, I say, hey, okay, raise your hand and tell me what your major is. Major is a great example of a nominal variable, and then it's kind of cool. I can graph it out and say, you know, there's X amount of psychology majors, X amount of math majors, nursing majors, etc. So that's kind of cool, but obviously we can't do this here. So I'm just gonna make up a few majors and throw in some categories. So let's say we have psychology, criminal justice, business, nursing, education. So let's say these are my 5 categories, right? So I have students who are psychology majors, students who are criminal justice majors, students that are business majors, students who are nursing majors, and students who are education majors. So let me just make up some numbers. So I have 5 students who are psychology majors, 10 that are criminal justice, 5 that are business, 15 that are nursing, and 12 that are education. So check it out. Let's draw it up. So again, frequency is going to go on the y-axis. So there's our funky looking F there, and then on our x-axis we're going to have major, right? Now, for our axis labels, I'm just going to go with the smaller category to the larger category. You could technically do it randomly, right? Because that's what nominal is. You can't rank the majors, right? So with our frequency polygon and our self-esteem scores, you couldn't put 4 before 1 and 3 after 4. It wouldn't make sense, right? Because they're ranked. 1 means low self-esteem, 4 means high self-esteem. So, but here, I'll just, okay. So I'll put psychology first because I'm a psychologist and the least amount of students are there. And then we'll go business. And then we'll go criminal justice. Okay, and then we'll go education. And then we'll go nursing. Okay, I forgot to write up the actual frequency value, so let me do that right now. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, are you ready? We're going to make some bars. So the key here, and the difference between a frequency polygon, or rather a histogram and a bar chart, is in the histogram the bars are touching. Because the data are continuous, right? And they're ranked, right? They're ranked and they're continuous, right? Remember self-esteem? 1, 1.1, 1.2, 1.3. All the way to 4, right? Continuous data. The bars are touching each other, okay? Here, they're not. They're not, right? There's no rank, right? And the data aren't continuous. Okay, so psychology. There's 5. Business. There's 5. Criminal justice. There's 10. Education. There's 12. Nursing. There's 15. You know, one thing I do with these graphs in the professional setting, and you'll see this in the SPSS activity, I love to put the values above the points. It makes it so much easier for the consumers of your data analytics to actually understand where exactly this bar is. So we'll use red, why not? 5, 5, 10, 12, 15. And that's the bar graph or bar chart for you. You know, not too complicated. This is something you probably have done before. So this concludes our Chapter 2 lecture. Thank you all. May the peace and grace of Christ be with you.